Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Voorhees, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. So I'd like to start off our event today by thanking Alteryx for sponsoring today's event. Alteryx is a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Tableau, Click, DataRobot, Tibco, Vertica, and TidalScale, to name just a few. Now, our past webinars are available on demand at datasciencecentral.com. And if you haven't had a chance to look at them, I encourage you to take a look because they provide some very useful insight into a wide variety of topics of interest to our data science community. Now, today's webinar is entitled Predictive Analytics for Supply Chain Management, and that'll be presented by Alteryx. And before we begin, I'd like to briefly review the format of today's webinar. Today's event will be an hour long. We'll have two presenters who I'll introduce in just a minute. There'll be 10 to 15 minutes of Q&A following the presentation, and today's event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. Now, I'd also like to encourage our attendees to provide questions throughout the presentation, because we'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Now, I'm very pleased to introduce today's speakers, Raz Nister with Keyrus and Scott Troutman with Alteryx. Now, Raz is Chief Data Scientist at Keyrus US. He comes from a background in the physical sciences, where he learned to use computers to help people understand complex problems. At Keyrus, he's worked with numerous clients across financial, retail, nonprofit, and consumer packaged goods sectors to empower organizations to use data to make better business decisions. Now, data science teams at Keyrus specialize using the latest machine learning techniques to build rich analytic solutions to answer complex business questions. Now, Scott joined Alteryx in 2016 and is currently Director of Product and Alliances. At Alteryx, Scott engages with partners and customers to address their challenges with self-service data analytics. Alteryx helps bring data analysts from being at the end of their rope to the edge of their seat with powerful, easy to design and use workflows that provide valuable insights and answers to complex questions. So Raz, Scott, hey, thanks for being with us today. We're looking forward to your presentation. Now, the retail and consumer packaged good industries are continuously looking to maximize margins across all aspects of their supply chain. Tight competition and increasing distribution costs can exert negative pressures on revenue, sink profits, or force companies to adopt unfavorable pricing strategies to keep pace with ever-evolving markets and consumer demands. So in today's Data Science Central webinar, the data experts from Alteryx and Keyrus will show us how organizations can model their entire supply chain, identify cost and distribution bottlenecks, keep store shelves stocked with accurate forecasting, and model the cost to serve a product across dynamic and complex distribution systems. So join us and discover how putting advanced analytics within reach of your organization can lead to disruptive and actionable insights for your business. So, Raz, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Thank you very much, Bill. It's certainly a pleasure to be here and speak with everyone. It's a great honor to give this webinar on Data Science Central. It's something we've looked forward to for a long time. I'd like to thank our partners, Alteryx, for providing us a great platform to use both in this webinar series, but also just with our clients in our day-to-day life. And we hope that by the end of this webinar, you'll have a good idea of some of the problems that we've tackled along solving supply chain issues and questions that our clients have had. We hope we could take a lot of those insights home and build upon them perhaps for your own business use cases. Thank you for calling us data experts, and my wife would certainly try to kind of talk down that type of thing. Lets my ego get too big here, but thank you very much, Bill, for that kind introduction. We are Keyrus. We are a data consulting company. We are worldwide. We have about 2,500 employees spread around about 15 countries. And we specialize in management consulting and digital experience. So here in the U.S., we're very much focused on data intelligence, so everything to do with data. We have a very wide and capable data engineering team that does everything from data architecture and Oracle, SQL, Hadoop. We have a very broad data visualization team using the BI tools like Tableau and Qlik and Power BI. And then we have the data science team, which I lead, which tries to specialize in answering some of the more complex analytical questions. And when I say I'm chief data scientist, again, that just means it's my position and my duty to kind of keep track of the budgets and the team allocations. And of course, to do all that, we're using Excel. So there you go. Very much, again, like to thank you for being here today, everyone on the line. If there's one goal that we try to achieve when we work with clients, it's really we just try to help them make better data-driven decisions. We like to see data being used actionably, tactically, on a very granular level to try to understand where gaps are in any process you may have, of trying to understand how we can optimize processes to make them more efficient, to either save costs, increase revenues, or to understand the impact that certain programs or promotions may have in given revenue streams. It's a very loaded statement, I have to say. My experience working with a lot of clients in the last 3 years that I've been at Keyrus is, it comes in several, I think, folds here. First, you have to understand the client's data. That's paramount. You have to understand where it's coming from, how to piece it together in meaningful ways. It's usually coming from all kinds of sources all over the place. So you really need to understand and have tools at your disposal to be able to kind of piece all that data together in meaningful ways. You definitely have to understand the client business. How do they make money? What are really their pain points? How can you increase sort of the bottom line? Yes, that's what everyone's chasing, but also, things, sometimes they're interested in things that are a bit more esoteric, like increasing, marketing share, or increasing share of clients of voice, or share of voice in marketing campaigns. So these things are, they're spread around sort of different clients that we've come across, but it's really trying to understand how the business operates at a fundamental level. And then the last kind of pillar of all this is really trying to understand how your solutions, how your analytics will help make the company better. It's not just building a dashboard, wham, bam, thank you, and then you leave. We sort of develop partnerships with a lot of our clients. We're continuously working with them to either improve what we've built upon or try to gain more insights into what we've built. And particularly with the data science, I like to emphasize that point, because data science has the propensity, I guess, or the possibility of just becoming sort of a research project if you're not careful. And you really have to think about how the insights can be used within an organization, and how you could communicate up to the C-level management about what you found. And I like to touch upon that throughout the talk as we describe some use cases. So I've been working with Keyrus for about 3 years. I started as a data analyst, and during that time I've worked with a variety of clients across different sectors. There was a few years where we were heavily focused in the financial industry, and now lately it seems to be in the CPG and retail space, particularly with clients like Dannon Yogurt, Heineken beer importers, Remy Cointreau USA, which is a cognac company importer here, AB InBev, which is a large beer company as well. And kind of these companies were almost all at the same spot in their analytics journey. They kind of had lots of data. They didn't really know how to piece it together. They didn't really know how to consolidate it and get insights out of it. So this talk was sort of geared towards, talking about supply chain in particular, but it's building upon the foundations of projects we've done in the data engineering visualization space at a lot of these clients. So what have we found as we go along the BI lifecycle, and what are people's expectations and their experiences? We found that most of these, particularly the CPG clients, are sort of around the level 1 or 2 kind of stage in their sort of analytic lifetime or analytic evolution. They have some traditional reporting. A lot of them use Excel for a lot of data prep and analysis. A lot of pivot tables with the millions of rows limits that you have in Excel, trying to grind things out by product, by market, splitting things up. They do really, the analysts, the business analysts really do understand the business. That's the key. And everyone really knows deeply and intimately how the business works and how to improve upon processes. It's almost like they need to be enabled to reach the next step. And they think perhaps sometimes that enablement requires extra people or extra expensive tools, but it's really not the case. And it's very rare that we kind of start with a client that's sort of at the level 3s already, sort of the agile analytics, where they kind of have all their data together in one spot in a meaningful way. They have a 360-degree view of their business, we like to say. In other words, they may see, they may have all their financials joined with their sales data, joined with their customer data, all very clean that they could use and leverage. But it's certainly even more rare that they're doing steps 4 and 5, which is starting to apply some of the more advanced techniques that we have at our disposal, especially in the data science space, doing predictive analytics, doing advanced machine learning to kind of model complex processes. And then once we do model and understand these processes, kind of optimize them and to communicate that back to the business. So that's where we kind of want to go with a lot of our clients, and I would say we usually start at around a level 2 or 2.5, maybe 3, and we kind of push them to the next level 4 and 5. And we'll see today how easy it is to kind of get over that energy barrier. It's not as out of reach as we think. So before we go there, we have a little poll question. For everyone online, just please quickly fill in the answer here. Where is your organization or your client's organization or the people you work with? Where is your organization within the BI lifecycle here? Let's take a little poll, and we'll just pause briefly to allow you to fill that in. Just click the radial circle and click submit. And I'm going to go to the next slide right now. And we'll see, yes, most people, you could see the spread very evenly split around levels 1, 2, or 3, and sort of ready to take that next step, to take the plunge into more actionable intelligence and to access some of the predictive analytics that we have at our disposal. So this talk, for the rest of this webinar series, will very much focus on how we can do that, specifically apply to supply chain problems, but hopefully to give you a scope and a tool set capable of tackling many other problems that you may come across in the business. So let's take a look at the supply chain in general. It's a very interesting problem set, I think, with supply chains, just because it's such a rich feature set and a rich set of data sources that you come across supply chains. Typically, you have manufacturers or importers who bring the products or make the products to market. And there's a whole bunch of data sets associated with that. A lot of sales and operations stuff, finance. They typically send out their products before it gets to the store shelves through a distributor system. And in the alcohol and beverage or spirits space, this distributor system is actually by law third-party, other companies that have to exist. Manufacturers of spirits and alcohol beverages cannot sell directly to accounts or to consumers. So there's a very wide-ranging and complex distribution network in the United States. For other clients that we've had, for example, for Danone in the yogurt space, they own a lot of their own distribution centers. They're sort of like warehouses, but they do act as almost independent business units. And then sometimes if you sell your products to large chains like Walmart or Costco, they may have their own distribution centers as well. And the point is here that they're going to have their own data set that somehow you're going to have to get. And it's going to be important to get that because you need to understand what shipments go in and what depletions come out to monitor things like inventory health, to make sure that product is flowing down to the accounts, and so on. Now at the account, in general for us, the data gets a little bit harder to get. Usually you could buy account level information from syndicated sources like Nielsen, IRI. Sometimes you can work out a specific deal with a particular, national account or marketing group level type ownership. Maybe get some like transactional data out of an account, but usually it's coming from a third party like research data or projected data from like a source such as Nielsen. And then down to the consumer finally, it becomes even harder to kind of get data associated with what the consumer is exactly doing, but you could sort of measure their response to brand awareness, their kind of participation on social media, demographics analysis, things like that, looking at census tract information, which is becoming more prevalent. So each point along the supply chain is very rich, I think, feature set and comes with some very interesting data sources here. And of course, to analyze, or to get insights about what's happening along the entire supply chain, we kind of hit the same stumbling blocks at each client that we work with. So first, everyone wants the 360-degree view of their business. So they have to kind of consolidate the data in meaningful ways already, and that's usually a big pain point. Second, there's perhaps some tools, capabilities, or software lacking. So for example, people are still using Excel. Why? I mean, there's some specific supply chain software out there, and they're very good for monitoring S&OP level type stuff. But people want to join finance data, and then they get some data set from Walmart, which is like completely outside the box, and they need to take that into account. So a lot of ad hoc and kind of big questions that arise go outside the scope of some of the software. So you need more capabilities in being able to handle that. The data gathering and data consolidation is always a problem. You need to connect the data in meaningful ways. You need to align data sources along products, states, and markets, and this type of thing. So it becomes sort of a very laborious task for some people to manage that in Excel. And then the last 2 points here, analytical expertise and productionized insights, it's kind of like a big pain point that we see that perhaps not talked about. Analytical expertise, a lot of people think you need to hire a data scientist or an advanced analytical data analyst to kind of make use of some of these routines. It's not quite the case. We hope to talk about that. And then productionizing the insights, like I said, to avoid the pitfall of any of your data science projects becoming just sort of like little research proof of concepts, you really have to be able to embed the insights or the analytical streams into the current workflows of the place, of your clients or of your organization. And you need to be able to have the insights communicated upstream to management and so that they could take actionable intelligence and from using language that they understand. Because if you start talking about p-values of fit and regression coefficients, people will tune out. So you really need to be able to communicate those results upwardly in a very efficient manner. So there is some tools that help us to kind of touch upon all these points and help us get to the end goal, which is to make better supply chain management decisions using data. And one of these tools is Alteryx. And to give you a little bit of an intro to Alteryx, I'll pass it off to my colleague Scott here, who will walk us through a brief introduction of the platform.
Thank you, Raz, and thank you all for joining us here this morning. Great to see so many of you here online. Yes, my name is Scott Trothan. I'm with Alteryx, and I wanted to take you through just a brief introduction to our software and our platform, as some of you may be familiar with us, some of you maybe not. So just to introduce you to who Alteryx is and what we do, Alteryx is the leading platform for self-service data analytics. It provides analysts with the unique ability to easily prep, blend, and analyze all of their data using a repeatable workflow, and then deploying and sharing analytics at scale for deeper insights in just hours, not weeks. It's useful to think of Alteryx as a repeatable workflow to prep, blend, and analyze all your data. First, we enable analysts to access, prep, and blend all the relevant data that they need for their analytics, whether that data is stored in Hadoop, a data warehouse, in the cloud, or on their desktop in Excel. And as Raz mentioned here earlier, especially in supply chain, the analysts that are working with the supply chain companies often are exposed to different types of data, different types of reports that they all have to bring into one source, into one workflow, if you will. And this is something that we see a lot of companies struggling with, whether it be information from Salesforce or information from third-party suppliers, whether you're trying to bring in social information, such as information from Twitter. This is all, you can all gain insight from these different data sources. So it's important to be able to bring those all together. And that's what Alteryx does. Data types can be structured, unstructured, or semi-structured. It doesn't matter. Alteryx can work with and join them all together on common fields or even geographic proximity. We have relationships with some of the leading providers of third-party data. So you can enrich your internally collected data with additional insights. The end result is that you can easily join data from multiple sources to create the analytic data set you need for analysis. And then finally, you can use the same workflow and the same intuitive user interface to perform your analytics, whether it be predictive, statistical, and spatial. The predictive capabilities within Alteryx are based on the R language. And so if you're familiar with R, you can even customize some of these tool sets, incorporate your own code or programming, and use it to further advance your predictive analytics. But the important part is you don't have to be familiar with R in order to use the predictive tools. We've got that covered for you. These tools require no coding expertise, but like I said, if you do have R programmer skills, that you can customize these tools or even create your own tools to be reused within Alteryx. Our spatial analytics tools utilize data from TomTom to build trait areas based on drive times or other variables to do sophisticated location or geospatial analysis. And then it's important to make it easy to share the deeper business insights you are producing. With a legacy analytic approach, analytic apps and reports often have to be created in another environment or even custom coded. With Alteryx, this step is just added to the end of the workflow to enable reporting, output data for visualization, or create analytic apps that allow business decision makers throughout your organization to customize and run their own analytics without having you create custom reports. And as you can see, you can visualize your data if you're a master at Tableau, or you're more of a Power BI user, or even if you want to take that data and put it back into Excel and visualize it there, that's fine. We can work with all of that. And then finally, Alteryx empowers data analysts in the line of business users in well over 1,000 different organizations across a wide range of industries, including retail and supply chain. From well-recognized global brands to small companies looking for a competitive differentiation, analysts in these organizations are the modern heroes. And these analysts are earning a seat in the boardroom because they're taking full advantage of the self-service data analytics capabilities within Alteryx and taking advantage of the platform. They're delivering the deeper insights that help their companies make the best decisions. And with that, Raz, I'm going to turn it back to you and let you take us through this journey to predictive analytics for supply chain and realizing how do we take users who may be more using more traditional BI methods, how do we take their game up a level here?
Thank you very much, Scott, for that overview. And I think the point to highlight here is how Scott emphasized that we're working with the actual analysts themselves, with the business users themselves. This is not like you need a developer, and that's the key here, because the analysts and the business users know how the business run. Like I mentioned, it's a matter of enabling them to do something they never thought possible before. And we're going to walk through a series of examples of similar type problems we've solved in a few places now, but the particular story in the flow path here was specific to Dannon Yogurts. And we started to take a look at some statistics and correlations. We'll just talk about that quickly. We were doing inventory forecasting to kind of show some of the forecasting capabilities, but what we really wanted to focus on was predictive models for supply chain and some of the questions associated with modeling cost to serve, which is a particular variable that people are interested in, and we'll explain that down the road here. again, so just to emphasize, the supply chain in the CPG space is very complicated. There's data coming from all over the place, and business users often spend a good portion, I would say, sometimes 50%, I'd hate to say it, of their time just putting data together and consolidating the data. So when Scott says, you could build a repeatable workflow, just think of the time you could save if you could just build something automated that could do this process for you. And that's just very key. And we've seen the struggle across the industries from high volume, very short product life cycle stuff in the yogurt manufacturing space where they have to get their product on the store shelves, otherwise it'll go bad, to the beer and spirits importer where perhaps the product doesn't go bad, but there's still some throughput, and the data sources are similar, the problems are similar, the scales perhaps change here and there, but everyone seems to be struggling with consolidating this data together in meaningful ways. And Alteryx here, we sort of have a screenshot of what the canvas and what the designer desktop tool looks like. Is a visual programming tool, and that's key. It's visual because you don't have to write syntax, you don't have to write like a little script or code. It's all visual, and this is kind of like the new age tools nowadays. We do visual ETL. So you can see that at the top here where it says browse, date and time now, directory, output data, text data. These are like some icons that perform specific functions or tasks that you would normally do with like a SQL script or maybe something in Python or R. And you just drag these icons down to the canvas, and this allows you to kind of build out a workflow that you see below here with the colored checkerboard kind of background in the canvas below. And it very easily allows you to connect to multiple data sources, bring in, union, join, summarize things up and down. And it's visual because you could just see the flow. It almost looks like an electrical circuit diagram. So there's no way this could become confusing because you just follow the lines of the flow. And second of all, Alteryx allows you to see the data at each step of transformation. So I could click on a particular little anchor, input and output anchor on any of the tools, and a little window pops up like the one at the bottom there that says results for this unique tool. And I can actually get a snapshot of what my data looks like at each step of the flow. So this is huge for us. This is why Alteryx is and these visual tools are faster time to value. And even for us, maybe we're a little bit more tech savvy just because of our training or our backgrounds. But even for us, it just saves so much time because we could see what's going on at each step of the flow and the process. So it's a visual tool because you drag things out to the canvas and build out a logical flow, which is easy to follow. But it's also a visual tool because you can see what's going on at each step. Excuse me.
And that's important, Raz, because as we found with some of our customers, the citizen data scientists that we work with on a daily basis, we found that the need for data to be verifiable and to be able to trust your data is a key step here. There's a lot of for a lot of folks who are working in Excel, you may struggle with if something is wrong, if there's a pivot table that's broken or just not working correctly, sometimes with these larger spreadsheets, it can be awfully tough to verify, or trying to figure out what's wrong with your workflow and what's going on. With Alteryx, we help to make data as visible as possible so that you can easily review and trust your data.
Exactly, that's a great point, and there's no way I think you can make it confusing, like I said, which is definitely one of its strong suits. And like Scott mentioned before, coupled with this ability to see your data at each step of the flow, and this great ETL capability that comes built into the tool, you also have spatial analysis, predictive analysis, like you see here on the screen, tool sets for time series forecasting, grouping, and just demographic analysis. So it's all right here in one canvas. You could string together complex flows, and so sorry guys, can you hear me? Yeah, I just got a notice.
Yes,
sorry, that Bill. Okay, great. Sorry about that. So as I was saying, you could string together complex flows that build upon your ETL solutions. And for the predictive routines in particular, you could see they sort of have the gamut of standard, predictive analysis that you would do, like boosted trees models, decision trees, random forests, gamma regression, linear regression, so on and so forth, all the way up to network neural net somewhere in here. Perhaps I forgot the icon. So there's a wealth of analytical capabilities that are embedded into the workflows. And to start off with the basic example, like whenever you kind of start a problem in the data science space, what you do, you poke around the data, you kind of take a look. And I want to highlight something that we did that turned into something meaningful, I think, for our clients, where we started to look at correlations between product sales, and it ended up being sort of a market basket analysis, and I'll explain what that is, which is all built into the tool, by the way. But you're kind of looking at the likelihood that two entities are correlated in time, so two products that sort of sell well together, probably ship well together. That was the idea. You can see example workflows underneath. Very simple to kind of build these out. Very simple to kind of see the data at each step. And certainly not something I would have been able to do in under 5 minutes in R or Python or what have you. Just very simple to drag the tool sets out and kind of answer questions already of how do my products trend over time? How do my product sales trend over time? What's my product mix and how is it correlated? And in particular for our client, it was useful to understand, if a person buys brand X first, how likely are they to purchase my product next, looking at specific transactional sales data. So what do we see? First, let's take a look at just sales over time. So this is like volume, for example. So you could think of volume as being a unit of a sale. Typically that's like maybe 12 bottles of something, if it's alcohol, or a certain number of yogurt packs of something. But you can see over time it's a very rich and dynamic kind of response. You sort of have this increasing peak and this kind of like hump over the summer months, and then there's always like a big kind of spike during the holiday times, and then things die down a little bit, and then the hump repeats, and then you kind of get a spike again. So you sort of have this something we've seen across like several clients. So you sort of have this rich kind of response. And what we'd want to know, if two products kind of sell well together, then they're going to have the same peaks and valleys. And we calculate a correlation matrix using the correlation tool very easily. And you can see that down there below in the green highlights. And you can kind of see what the density plot of those sales for the two products look like in the top right there. So it's looking like it might be correlated. Usually around 0.7, Pearson correlation, I start to get interested. 0.6 maybe on a good day, but 0.7 usually things are starting to look like they're correlated in time. And you can plot out other things like scatter plots and distributions of the sales. So these are just something we do just to even start the analysis. We need to understand which features are correlated. So we don't want to like fit on multiply correlated or linearly dependent kind of features. So this is just something we did. And we're sitting there with the analyst doing this, and he always thought like, wow, this is like very complicated things. But no, it's very accessible, and it was like literally in 5 minutes we could quickly understand which sort of brands or which products tended to sell well together. And this led to a deeper question, which was to sort of understand specifically at a transactional level how products or how given SKUs or how brands and how competitor brands sell in sort of conjunction with each other. And we were fortunate enough to get actual transaction level data from an account that we were working with. They gave us sort of like loyalty member info of actual transactions, only for yogurt in this particular case, but it contained like, competitor brands to Danone. So for example, Faye and Chobani, and kind of if we're trying to understand if somebody bought Chobani first, how likely are they to buy a Danone brand second? And we're looking to do this with a technique called market basket analysis, which sort of measures the likelihood and the number of occurrences of particular sequences of purchases for occurring. And there's a very classic example of a grocery store doing this. And of course, the idea is to come up with cross-promotional items in the marketing campaigns for this. And there's a very classical example of you'd probably want to put your diapers next to your beer sections for the dads going to the grocery store late at night to pick up diapers, but they're also interested in getting some beer. Here we're only doing for yogurts, but what we found was a few interesting things. So you kind of get just think of these dots in the coloring as being the likelihood of certain occurrences of happening. So we kind of saw that people tended to buy plain yogurt all the time and the lighter yogurts. And that's true because it's used for cooking primarily too, not just for eating or used for breakfast foods and things like that. Whereas some of the other flavored yogurts were purchased in a bit more specific sequences. And what I'd like to emphasize is that we sort of did this we did a little bit of feature set engineering here. We sort of ranked the darkness of the yogurt, if you will, like on some linear scale that we made up. So like a 5 is like a mixed berry or blueberry, strawberry maybe a 4, and so on. And down in the 2 and 1 kind of rankings, you have like peach, honey, and yogurt. And what we found was that if you tended to buy darker yogurts, like blueberry and mixed berry and cherry, you tended to stay within that flavor profile. So we're trying to understand, how we can impact consumer marketing campaigns here. And what we got out of this was perhaps we should try making some value-packed promotions where we bundle sort of darker flavors together and sort of lighter flavors together. And that was something the marketing team, that was some insights the marketing team understood what we were saying. And we weren't talking about the actual market basket analysis results. We were just kind of telling them the high-level message out of that. And that was something they understood and kind of took back to their teams to try to work on. So this was just a quick example of, just trying to understand how just looking at the data over time, first of all, is important. Trying to understand how products sell together, how brands sell together. And then, you could do this analysis with other KPIs, so sales perhaps and some display KPIs or some distribution KPIs, and you can really see how things correlate over time to try to fill in that causality picture, try to understand what goes into, what affects the sale. But we primarily did this, first of all, to ramp up to do a few more complicated things, which I'll talk about later on. So the next thing we tackled was some time series forecasting, and this became relevant because the company was really trying to gauge and to monitor inventory levels in the distribution center. So like I say, usually have shipments going in and usually have depletions coming out. And you would think they kind of look the same over time, but not really, because you have these build-up to shipments probably around the end of the quarter when people are trying to hit their numbers, and depletions kind of roll off as consumer appetites go up and down. So you're trying to model these two kind of complex feature and time series data, and you always want to maintain enough inventory to satisfy consumer demand. So typically people would use some rate of sales type of analysis, which is kind of a way, pretty much like a linear kind of approximation to some of these, as we've seen in the past, some of these more complicated time series responses. And you can see the Alteryx flow underneath. Very simple. Again, those pinkish circular tools and icons are actually the forecast models, the ETS and ARIMA forecast models, again, coupled to R, like Scott mentioned. And we have some other interesting kind of like black and white kind of tool sets, which I'll mention in a second. But the idea was to kind of model shipments going in, model depletions coming out, which you could kind of see the two response curves here, right? And you can see it's not a straight line. It doesn't do it justice. You can't just do like a rate of sale analysis because there's such a rich kind of response dependent on the seasonality here. And the idea would be to take the shipments minus the depletions and see if, at any point in the next 6 months you actually have a problem or a low inventory situation. And if you take a look at one of the icons here, and I just wanted to bring up some sample menus that you see in the bottom right here. Again, they are just R code. You can open these up and read the R code, but what you can see is that the icons present you kind of very easy to use user interface, which allows you to set the model parameters in a very fast and kind of fluid way without you actually having to modify the actual R code. So this, again, saves time and, again, makes it very easy to use. So what we did here was, okay, we built a model, and we were thinking like, that's great. So we made we kind of made a forecast analysis for the inventory levels, and that was great for the analysts we were working with, but they wanted to push this out to sort of the brand managers working in market. So how are you going to take a forecasting model and push it out to these people? Well, one way was using those kind of black and white icons we saw, which are very useful for creating an app out of your workflow. And you could publish this app on the Alteryx gallery, which is sort of an app store that will allow users to access the logic that you built. Maybe they could go in and on the screenshot on the right here, change some parameters like the product and the kind of state that they're looking at, maybe change some dates, click finish, and it'll actually use the forecasting model specific to the parameters that they input. So that's very useful, and that's one way to productionize the insights, is to give people access to the workflows. And this is a way of embedding in their kind of standard day-to-day. And if you expose an easy-to-use and easy-to-access interface for them, then they're much more likely to use the routines. And what do you get at the end of this? Alteryx also comes with a very capable report building, sort of pixel-perfect report building capabilities. You see an example here, a very hasty example I threw together on the right-hand side. This would be like a PDF summary output of sort of the inventory health at any given point in the next 6 months. You're careful to look at the forecast levels where the inventory perhaps drops down below a given value. But this is like a PDF report that the brand manager in that market would get. And you could take this to a distributor and say, you know what, in the next 3 months, because we're gonna expect a peak coming up for the holiday season, I think we need to like get more stock in just to cover consumer demands. And that's like something very actionable and tactical that you could bring into the discussion with your distributor. Again, so this is emphasizing how to make these analytics readily available, embedded in people's work stream, make easy to use interfaces to access this stuff. And of course, what we really wanted to do was some predictive analytics and build like complex models to answer some deeper questions. So we're going to use decision trees and random forests and neural nets here to kind of look at a particular question along the supply chain that we were tasked with answering. But in general, I think these are just powerful routines you can use in a lot of given places. All right, so let's take a look first at the data that we're going to be dealing with here. So we're talking about shipments going into a distribution center, and we're looking at fields that have like the distribution company. This is all like fake data. That's why the names are kind of funny. The distribution company that's tasked with bringing the product to the distribution center, the account owner, the utilization rate, which is like the fill rate of the vehicle that's taking it there, the cost to serve, which is a very important metric, which is like how much does it cost to bring this product to market, the volume associated with it, and then the field that we want to predict on if it was late or not, right? And late shipments, particularly for like the yogurt industry, because their product lifetime is like so short, it's pretty killer. So you want to try to avoid late shipments or late any kind of late deliveries. So how do you build predictive models in Alteryx? Here you see a sample workflow again. It looks very simple. You just kind of drag the various models up to the canvas. And within 5 minutes, you could build like 4 or 5 kind of complex predictive models. And again, the interface that you see in the bottom right here for the random forest routine in particular is very easy to use, very accessible. The R code behind each of these is open source. You could read it. You could go into each tool and read the R code. But again, the interface will give you the ability to kind of set up what you want to do very quickly. So in under 5 minutes, you could build 5 models, like very quickly, to kind of just gauge what's going on. And you can see here that the target variable that we're predicting on is that late field, yes or no. And you could choose, which features go into there. And note that one of the coolest things about these models is that you could predict on both sort of string and numeric fields quite easily, which some of the regression algorithms are not capable of doing. So what do you get? You get the standard things out of this. There's already precompiled R reports that you get out of each model. On the left, you can kind of get the typical ROC curves to see which model is doing best on a given test set of data. You can kind of see the random forest model is kind of predicting pretty well here. You get the kind of Gini coefficient plots out of the random forest in particular. It tells you which variables or features are kind of important to the results. And then you could go in and kind of even tweak the analysis and dump out things that I usually like to look at, which are like partial response curves and things like that. And again, maybe that's not like standard output as part of the tool, but it's definitely something I could go in and tweak myself. So what do we got? We made a model we could predict whether we're late or not, but what we really wanted to do was actually predict that cost to serve. So instead of predicting if we're going to be late or not, let's actually predict on that numerical field cost to serve out of the same kind of other features that go into it. And what you see on the right is sort of the result of that, where the bars represent the actual cost to serve, and then the orange line is sort of like the predicted model version. And we have a model to predict cost to serve. And then you could start doing what-if analysis. You could start optimizing this to understand, you know, what's the impact of a given market or given distribution center on this. And this was the real goal of the project. And we got to this point and said, okay, supply chain team, we have a model that you can now play with. How do you want to play with it? Do you want us to embed this in the dashboard? Do you want us to make this, you know, into some kind of static report? Do you want us to run a genetic algorithm on top of it to kind of tell you what is the best combination of features, you know, to minimize the cost to serve? And that's where we're currently at with the client at this point. We have the model, and that's the important piece. Next is kind of using it in meaningful ways. So that's great, but so what? I mean, we built like 5 models. Is that what we really did in life? Well, actually, no. You can't really just build 5 models, right? If you want to win Kaggle competitions, you got to build like 500 models. And what I would invite you to do is take a look at the Alteryx gallery online and go into the predictive district, where you'll find like a lot of different tools for doing like cross-validation techniques. There's like a data robot connector that we're maintaining going forward to allow you to access some of the more automated data science and machine learning streams of work that you'll be able to do, where you don't just fit 4 models, you fit like 400 by making various training and test sets. And that's kind of the flow path you'd want to follow, right? So you don't get just one answer, you get like a distribution of possible answers from each of your models. And I would say that overall we were able to kind of tackle with this one platform, with the Alteryx Analytics platform, all of the pain points that we were seeing the business users and analytic experts kind of struggling with at our organizations. We gave them a complete, you know, overview of their business, and we're able to consolidate all their data together. We're also able to, you know, give them the analytical expertise and allow them to do stuff they never thought possible before by very easily making accessible these types of you know, predictive routines, bringing them into their sphere of capabilities, and also productionizing the results in ways where they didn't have to learn how to code like a web page or an API, right? So for next steps, I would invite you guys to take a look at the predictive kit on Alteryx, especially the gallery and the trial, and probably some of the product trainings. It's a very vibrant community, and provided me with a lot of insight, certainly. And with that, I'd like to pass it back to Bill to handle the Q&A period.
Well, hey, Raz, Scott, thanks for that excellent presentation. We'll get started with today's Q&A session, and I want to thank the audience for their participation. We've had a lot of questions that have come in, and we'll do our best to get through all of them in the time remaining. So during this Q&A session, I'll leave up this screen with contact information for Raz and Scott if you'd like to contact them following today's webinar. So let's get started. Raz, maybe for you, the audience has wondered, is there a set playbook for the types of predictive modeling that you use with clients, or is it all experimental? I saw you do some champion model comparison there. How do you decide your predictive modeling approach with each client?
That's a great question, Bill. So typically, I'm kind of a chuck everything into a random forest to get started type of guy. I know it sounds bad, but I just like to know what's going on. But there's really no reason to pick, you know, one stream or one predictive model over the other. And the way the platform is set up these days, there's no reason not to build 500 models of varying, you know, algorithms. So very rarely do I tackle a problem with just one model, but I would definitely try neural nets, SVM, random forest, you know, the boosted trees method, and all working in conjunction, taking the results together in a sort of ensemble to kind of get an idea of which model might, yes, perform better, but which result is actually more trustworthy as well. So no need to just build one or two models. Use the scalability of the platforms and take it to the next level. Build hundreds of models.
Well, thanks for that answer, and yeah, completely agree. Now, I saw you do some presentation about being able to do what-if scenarios and comparisons to KPIs. The audience would like a little more clarification on that. Can you talk about how easy it is or how you would go about doing what-if modeling with Alteryx as support?
Yeah, that's a great question. So once you build a model in Alteryx, you could save it. It's like save it to like some Alteryx specific format, very similar to if you'd save a model in R as an RDA file. You could set up a sort of gallery app that'll allow you to tweak inputs to that model or tweak sort of data flows into that model, which you could then read into like a simple flow that takes that file or that model that you built and just kind of applies, the user-defined parameters that go into it. We've done other things where we've taken that sort of either that RDA file from R or some other proprietary file that stores the model information and exposes it in dashboards and provided people with sliders or perhaps, like radial buttons, or put it in sort of a web page format that allows them to kind of set some parameters up, and then either, an API in the back or the dashboard via integration with R or in the gallery with Alteryx would take those inputs and run it through the saved model.
Okay, well, thank you very much.
To get an appropriate output.
Yep, got it. And that leads, I think, into this next audience question. And they're wondering, does everybody involved in this analysis have to be running Alteryx or just the analyst? And I saw you illustrated some use of Alteryx apps, and that may be the dividing line. How do you decide who has to run Alteryx and who can simply receive output? Right,
that's a great question, and yep, that's the dividing line for sure. We can publish apps to the Alteryx gallery, and the Alteryx gallery is really just kind of like a web page around the Alteryx API set up for you, so you don't have to do like the actual hard work to expose that API yourself. And the analysts who are working with the models and building the forecasts or building the predictive routines would be the ones working with Alteryx specifically. They would publish the app to the gallery, and then other users could log on with, with kind of just a user license and be able to access those flows and those routines and the logic behind them to generate their own custom reports and to generate at least reports tailored to their custom inputs.
Well, thank you for that answer. Now, obviously, Alteryx is very well known for its blending capability. And the audience is asking, well, how does it actually do that? And beyond that, it's probably not just a piece of cake. What sort of challenges have you had to deal with in combining input streams and pre-processing them?
That's a great question. So usually the ETL component is 80 to 90% of our work, right? I mean, the models doing predictive like analysis and machine learning is not going to really work out for you if the data is not set up properly. And setting the data up is kind of majority of the labor that we see. So how do you combine things together in meaningful ways? It doesn't have to be in Alteryx. You'd sort of do the same level of ETL and mapping and data cleaning that you do like maybe in SQL or SSIS or any other ETL tool. It's just going to happen a lot faster in Alteryx. So for example, when we take Nielsen syndicated data, which is kind of a pain point because of the way the data is rolled up and aggregated, and how do we connect that to a client's custom sales data? That's always a pain point. One, we have to map the product names and make sure the levels of Nielsen correspond to like sort of the product levels in our client. That's sort of just like industry knowledge that you have to be able to do that. The Nielsen markets are a little bit different, and the zones and the geographic entities. So we can look at Alteryx to tell us at an account level, which accounts are in either our client-specific geographic zones and which ones overlap in the Nielsen ones, and sort of understand how we can map one to the other that way. So again, we would do this in any tool set. It's just going to be faster in Alteryx because it allows you to see the data at each step. So how to join the data together in meaningful ways is probably the main component of our workload on a daily basis. I would say, understanding what the final product should be is just a lot of trial and error and maybe perhaps even a little bit of experience. We've done it a lot in the CPG space now, so I could kind of say, yeah, I kind of understand how to work with these various data sets and these data sources. But it's still, every new client is a new challenge and requires a specific understanding about where the data comes from and how it's laid out in a particular way.
Well, Raz, thanks. That's a great answer. Scott, maybe this one's for you from our audience. You talked about the platform being based on R code, and so the audience asked two questions. First of all, what other formats do you support? For example, SPSS or PMML or SAS. And finally, the audience is also asking, well, can I take that entire graphic workflow of blending and export it as R code that I can modify separate from Alteryx?
To answer the first question, we work with a number of those formats. The major exception would be Python. Python code is not, we currently do not work with Python, but the other formats we do work with. To answer the second question, I don't know if I've heard of that being done, but at the same time, again, because our R code is fully customizable, if you wanted to export some of that data and then work with it within your own coded environment, if you will, that is possible, I believe. I don't see any reason why it wouldn't be. So it's just a matter of, it's, again, we're helping you save time and gain back a little bit of your day when it comes to these very complex models. So whichever environment you feel most comfortable in, you should work with. But at the same time, whether you work with the predictive tools or code them within Alteryx, or you export that data and work with it in your own environment, you're pretty flexible either way.
Well, Raz, Scott, hey, thank you for some great answers to some very good questions. And for those of you that asked questions today that weren't answered, we'll be sending all the unanswered questions to Raz, Scott, and the Alteryx team so they can follow up with you after today's webinar. I have just a few quick announcements. If you would please mark your calendar for September 13th, that's our next DSC webinar, which is going to be Powerful, Flexible, and Accessible Code-Free Data Science, sponsored by IBM. Now also remember that today's taping will be available for on-demand viewing later today, and you can find that on the home page of Data Science Central in the Webinar tab located at the top of the page. Well, this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions. A special thanks again to Alteryx for their sponsorship, as well as to our speakers today, Raz Nister and Scott Trothan, for their insight into today's topic. Now, my name is Bill Voorhees. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on September 13th. Have a great day.